ease of ionic bond formation. Yes or no? What is lattice energy? This is the energy released. 1 gram mole ionic compound formed from its isolated ion, which decides the stability of ionic compound, which decides the strength of ionic compound, which decides the ease of formation of ionic bond. Ease of ionic bond formation. Not only this, which decides the melting point, boiling point, which decides the solubility of ionic compound. Not only that, other property. Not only that, other properties of ionic compound, other properties like melting point, boiling point, solubility, conductivity, okay, conductivity, etc. Conductivity, etc. of ionic compounds. That is the reason why I didn't explain ionic compound properties. So a simple lattice energy. What is a lattice energy? This is the released energy. 1 gram mole of ionic compound formed from isolated ions. So the amount of energy depends upon released theoretical calculation. This lattice energy calculated theoretically by okay, previous Born-Landau equation. Yes, sir, not very important. Yes, not very important. Yesterday, that is why I went very fast, because just I have to introduce how it was written in your material. Yes or no? You don't have a clear explanation in your material. Just they given direct formulas. But how do they get? Number 2. Experimentally, lattice energy calculated or determined by Born-HABER cycle. These are important. This is very important. That means the lattice energy, how much lattice energy was formed, that will be explained by Born-HABER cycle. Understood? This Born-HABER cycle is based on what is that? Hess's law. Is based on Hess's law. Number 2, to explain this Born-HABER cycle, okay, before explaining Born-HABER cycle, I have to explain what is that Hess's law and what is our target and lattice energy determination or calculation by using Born-HABER cycle. To explain before Born-HABER cycle, I will explain 2 words. One is before Born-HABER cycle, we should learn what is that? Hess's law. Second point, you should learn what is that? Enthalpy. Third one, enthalpy of formation and what is formation reaction. These are the some few words we have to discuss. I'm sorry. Before Born-HABER cycle, we should learn minimum these points. If we know this point, then only it is easy. I think everybody understood? Yes. Who is that? Prasad. What is your doubt?
Sir, will you allow to upload videos in YouTube?
No. It is illegal according to me. I thought yesterday. Because if I allow you, I am what is a provoking you. That is, if it is there, no, if they know to that Narayana, they put a case also on me. They
Sir,
can put a case.
not
The
put
reason.
public.
I'm sorry. Okay, so before Born-Haber cycle, we should learn these points. First, I will explain one by one. First, SS law. First, I will explain SS law. What is SS law? Okay, na? Here, a boy is at A. He want to reach to D. He has used one path. Okay, na? He has used one path. And he has used another paths also. It is Galilu, that is streets. This is a main road. Okay, here A to D, the energy absorbed or released is Q. Absorbed or released. Please remember. Okay, first I will tell you enthalpy. What is enthalpy? It is a heat content present in a substance. Heat content present in a substance cannot determine directly. Always we are calculating enthalpy change only. Enthalpy change only. Enthalpy change is shown by delta H. I think first word you understood. What is enthalpy? Heat content of a substance. It cannot directly determine. Always calculating enthalpy change. Everywhere we are writing enthalpy change. We are not writing H. Okay. So if delta H is zero negative, that is exothermic, energy released. Delta H is positive, endothermic, energy is absorbed. Please, energy released process. Endothermic, energy or heat absorbed process. You please remember that. So, if A to B, energy may be absorbed or released, Q, and Q1, let us say Q2, let us say Q3. What is Hess's law says that Q is equal to Q1 plus Q2, Q3. What is that, sir?
Excuse me, sir.
Tell me.
Sir, what is the difference between enthalpy and ionization enthalpy, sir?
Sir, enthalpy is the term for every process you can use.
Okay, sir. Okay, sir.
But if you use for ionization
Ionization
enthalpy.
enthalpy, sir.
If you use for electron affinity, electron gain enthalpy.
Okay, sir. Okay, sir. Understood,
Enthalpy
sir.
is the term wherever energy changes occur.
Okay, sir.
Understood?
Okay. Understood, sir.
Enthalpy is the term wherever energy is absorbed, energy is released. We are using the term. Understood?
Okay, sir. Yes, understood, sir.
Okay. Now you carefully observe. That is why I am going very slowly.
Okay, sir.
Okay. What is SS law? Okay. If a thermodynamical TD means thermodynamical process takes place. Thermodynamical. Okay. If a thermodynamical process takes place in single step or in several steps if a thermodynamical process takes place, process means it may be reaction also. If a thermodynamical process or reaction takes place in a single step or several steps, the energy change remains constant or remains same. If it is takes place in one step, this is in step 1, this is in several steps or different steps. The same process takes place in single step or in several steps, but the energy change remains the same. And the Q is equal to Q1 plus Q2 plus Q3. For example, for your convenience, I will tell you one example. Okay, carbon combusted in oxygen produces carbon dioxide. Always combustion and tagalbettadam. Combustion mean burning. Burning always releases heat. Let us say Q1. Okay. Why? I am showing minus. Minus is always exothermic and energy released. C plus, this is A. Okay. The same carbon dioxide I can get another way. C plus of O2 gives rise CO. And the same time, CO plus of O2 gives rise CO2. I got CO2 in single step. I got CO2 in 2 steps. In the first reaction, delta H is equal to minus Q1. For second reaction, delta H is equal to minus Q2. And the same carbon dioxide I got in single step or 2 steps. C plus O2, CO plus of O2, CO2. According to Hess's law, minus Q1 is equal to minus Q1 plus of minus Q2. And the energy change in single step is equal to energy change takes place in different steps. I thought everybody understood. This is about the Hess law. Understood? Anybody having the doubt? You can raise your doubt. Chandra Sai.
Sir.
చెప్పండి బోలియో
సార్ ఒకసారి సార్ అంటే లైక్ ఎస్టర్డే చాలా ఫాస్ట్ గా తాగా సార్ రాయడానికి కొంచెం ఎస్టర్డే చాలా ఫాస్ట్ గా తాగా సార్ మీరు అంటే ఈ రోజు కొంచెం అంటే మీరు ఫాస్ట్ గా చెప్పండి సార్ టీచింగ్ చేయండి కానీ కొంచెం రాయడానికి టైం ఇస్తారా సార్
అదే దట్ ఈస్ I am writing slowly. If possible, you write. Otherwise, I will share my notes after completion of class. Morning only, evening only I will share. Okay, na?
Okay, sir.
Even if I am not going to share by your principal, sir, any one of you put, hi, sir, this is what is 11 to 12 class. You put, I will send that notes to you.
Okay, sir.
A message to me. Okay, na?
Okay, sir.
I will go like this. If it is possible, write. Otherwise, you please come into the notes. Okay, na?
Ha, sir.
Mostly I will write like this. Sir, whenever I am doing calculation, we are going faster. We have to write because if I am giving the time, because it is not a live class. Generally, why I am not giving the time to write the notes mean it is not a live class. If it is the live class, there is no problem as the student is sitting or not. If it is not the live class, okay, some students are getting bored and they left from the class. That is the reason why I am not giving 100% sufficient time to write the notes.
Okay, sir.
Please forgive me in this session, in this cause. Okay. Now this is about that. What is that? SS law. I think everybody understood that SS law and everybody understood enthalpy. Now I am going for another word. I am going to use in BORN-HABER cycle. Another word is what? Third word, formation reaction. Formation reaction. Generally, what is the purpose of formation reaction? Okay, any compound or substance formed from its own elements. Yes, let us see example. AB2 is a compound formed from its own element A and its own element B2. A came from A only, B came from B. Okay, you are not understanding. I know very well. If it is carbon dioxide is formed from carbon and oxygen, yes, this is a formation reaction. Why? Carbon dioxide, carbon came from carbon, oxygen came from its element O2. Yes, elemental form of oxygen O2 at room temperature. Next, you see the same carbon dioxide came from CO plus of O2. And it is element Oxygen came from O2. Okay. Is it carbon came from O2? Sir, carbon? No. Therefore, it is not a formation reaction. The elements present in the compound should be come from its own element in a reaction. Then that reaction is called formation reaction. Okay. I will show you one more example. Sulfur plus O2 given SO2. Yes, formation reaction. Sulfur came from sulfur. O came from O2. Yes, formation reaction. Now you go for one more example. Hg plus half O2 gives rise HGO. Yes, mercury came from mercury, O came from O. Sir, you are some students are getting doubt. Sir, why don't you write for like this, sir? 2Hg plus O2 gives rise to HGO. Sir, is it a formation reaction? Yes. But you please remember that formation reaction, you please, okay, express for 1 mole formation. 1 mole only. Here, how many moles are formed? 2 moles. That is why I am writing like this. And please express for 1 mole. For 1 mole, it is like this. For 2 mole, no problem. But formation reaction in this one, mercury is formed from mercury, oxygen is coming from oxide. Okay, I am giving one more example. Okay, N2 plus 3H2 gives rise to NH3. Is it a formation reaction? Yes. Nitrogen came from nitrogen, hydrogen came from hydrogen. But instead of showing, this is the better way. N2 plus 3 by 2 H2 of N2 become NH3. Yes, per 1 mole you are writing. I thought everybody understood formation reaction. Now, I am not requiring formation reaction. I am requiring enthalpy of formation. I am requiring enthalpy of formation. What is enthalpy of formation? Change in enthalpy in formation reaction. What is enthalpy of formation? That is change in enthalpy in a formation reaction. Okay. Otherwise, perfect definition if you require. Okay. The energy released or required. Okay. The energy released or required. Okay. To form 1 mole of compound, 1 mole of compound from its own elements. Yes, from its own element, 1 mole of compound formed is called enthalpy formation reaction. So the energy released or taken is called enthalpy change. That is why I am showing like this. You please see. Enthalpy of formation delta H, change in enthalpy in a formation reaction. Now you see C plus O2 gives rise CO2. It is a enthalpy of formation reaction. Yes. Carbon came from carbon, oxygen came from O2. Then delta H is equal to minus 393.6 kilojoules per mole. Now this energy is called enthalpy of formation. Why? It came from carbon and oxygen. I thought everybody understood. Okay, so change in enthalpy in a formation reaction is called enthalpy of formation. So all the terms you understood now? Okay. All the terms understood. Before that, some more terms also I will tell you. For example, a element M is there. It become, M is in gaseous state. It become gaseous ion. What you call this is ionization reaction. Ionization reaction. The energy change, okay, always positive. This is called ionization enthalpy. Okay, you know this point. And one more point I want to give. A is a element. It has taken one electron. It become A minus. What is this reaction? Huh? Electron gain. That is electron affinity. Okay, the energy released is called electron affinity. If electron affinity is negative, electron gain enthalpy is positive. You know in your periodic table lesson. Your sir has explained about this. Whenever a element take electron, it become A minus. A gaseous A takes electron, it become A minus. That is called electron affinity. Electron affinity is always released energy. Ionization is always taken energy. These points are required for my BORN-HABER cycle. Now I am going for BORN-HABER cycle. Anybody having the doubt now? I thought nobody having the doubt. I thought previously 5 minutes back 137 students. Now it become 132, 131. Chandra Sai.
Sir?
Cheppandi, bol, fast.
Sir, in the enthalpy formation, I can understand your handwriting, sir. Can you move right? I'll show you.
Okay. Divit Reddy.
Sir, from second electron affinity, its energy is absorbed, no, sir?
Electron, second I am not writing, first only.
Only first, sir?
Second only
Okay.
enthalpy absorbed, 100% correct, you are right.
Yes.
A minus
Sir.
become A minus 2. Energy is required. I am not talking about this one, okay?
Only, we have to consider only first, everything first, no,
I am
sir?
considering first for my
Okay,
convenience.
sir. Okay, sir.
Number
Okay,
two,
sir.
change in enthalpy in a formation reaction is called
Oh,
enthalpy of formation. The
okay.
energy released are required to form 1 mole of compound from its own elements. Another way definition. Now students, I am going for BORN-HABER cycle. So if you attend in the afternoon session, I will explain ionic compound properties. Now students, I am going for BORN-HABER cycle. What is the purpose of BORN-HABER cycle actually? And what is that? Lattice energy calculation. Actually, this is not original purpose is this. Another purpose is there, but we are using this purpose. Okay. I will write one example you see. By taking NaCl formation, okay, we are calculating lattice energy. Okay, by taking NaCl formation, we are calculating lattice energy. And NaCl I am taking as example. Okay, na? Now, let us come one by one. See carefully. Here sodium. Generally sodium in atomic, what is that? Room temperature exists as solid. Taken chlorine. Chlorine generally exists as Cl2 at room temperature as a gas. But forms, what is that? Sodium chloride, a solid ionic crystal. Generally, chlorine, I am taking 1 molecule, 1 mole. Always you should write for 1 mole. That is why it requires half chlorine. Yes or no? Sodium plus half chlorine gives rise NaCl. Why do I write half here? Because half 1 NaCl, 1 Cl only required. Sir, why don't you write Cl? Sir, you write like this, na? Sir, Na plus Cl. No, Cl atomic state is not existed under room temperature. Chlorine existed as chlorine molecule under room temperature. You should not write like this. Okay, na students? Okay, it's over. Now, here what you have to write? Sodium came from sodium, chlorine came from chlorine. Now, which reaction it is? Anybody? Which reaction that is? Chandrasai. Sodium came from sodium, chlorine came from chlorine. Then which reaction that is? Divit Reddy. Yes. Sai Charani.
Formation reaction, sir.
Very good. Excellent. This is a formation reaction. That is why I explained what is formation reaction. A compound formed from its own elements. That is called formation reaction. Then the energy required or released, you call as formation, enthalpy of formation. So here, generally, in this case, energy was released. But generally, it may be released or it may be taken. But in sodium chloride, energy was released. That's why I put minus. Okay. So, this is single step. In a single step, if the same sodium chloride formed in several steps, what happened? Yes, sodium first it become sodium gas. Sodium solid become sodium gas. Sodium solid become sodium gas is called sublimation. Sodium solid becomes sodium gas is called sublimation. Correct or not? Whenever a solid directly become gas is called sublimation. Sir, for every sublimation, and for example, ice to become ice and water. Ice become water vapor. Is it energy required or energy released? Always energy required. That is enthalpy of sublimation. Sir, why do you write like this? For every energy change, I am writing delta H. It is required. That is why plus enthalpy of sublimation. The energy required is called enthalpy of sublimation. Now, second point. Okay. That Na solid become, Na gas. This Na gas become Na plus gaseous ion by removing electron. What you call this process? Ionization. This process you call ionization. Here energy required or removed? Energy is required. That is why it is called enthalpy of ionization. It is also required. That is why plus. Released minus. So this is a enthalpy of sublimation. This is a enthalpy of ionization. For this process energy required. For this process energy required. Now one chlorine molecule become chlorine atoms. Chlorine already in gaseous state. It is chlorine gaseous ion. This is called dissociation generally. Generally you call dissociation. But I am taking chlorine molecule or chlorine atom. One chlorine atom. This is called enthalpy of dissociation. But I am not taking two chlorines. I am taking one chlorine. That means I have to take half energy. Is it correct or not? Once again, anybody having the doubt? Once again, anybody having the doubt? Nobody. Yes. So Arshavardhan, tell me.
Sir, can you explain? Hello, sir.
Cheppandi.
Can you explain dissociation?
Yes, I am going there. Chlorine is a molecule. I am converting them into chlorine gas. It is called which process?
Dissociation.
Dissociation. So dissociation always requires energy, releases energy. Dissociation means I am requiring some energy. Best two friends are there. I want to separate them. I have to use some, what is that? Gossips on them. Is it right?
Yes, sir.
Like mean I am to supply some energy on them. Yes, that is called dissociation energy. But I am taking two chlorines or one chlorine here.
Sir.
I am taking one chlorine or two chlorines.
Two chlorines, sir.
I am taking one chlorine in the reaction. But there are how many chlorine? Two chlorine. That is mean I am converting Cl2 molecule to first Cl. Cl2 molecule. And you don't think this first. Okay. Yes. I am converting Cl2 molecule to Cl. Okay. But the energy release is called enthalpy of dissociation. But I am taking one chlorine only. That is why I am taking half of the energy. Why? Because I am requiring one chlorine. So enthalpy of dissociation by 2. But this is also a positive. Why?
Okay, sir.
Always required energy. I think understood?
Yes, sir.
Now, this Cl is already gas. this become Cl minus by taking one electron. By taking one electron, it becomes Cl minus gas. This is called electron affinity. Electron affinity is always a minus. Why? For first electron affinity is always minus. Now this Na plus and Cl minus combine produces what? NaCl. Whenever Na plus and Cl minus combine produces sodium chloride. 1 mole of ionic compound formed from its gaseous ions. Then energy is called lattice energy. So this attraction lattice energy is called minus released energy. Whenever two ion combines and produces 1 mole of ionic compound, the energy released you call lattice energy. Yesterday onwards you are reading the definition. So this is multi-step. This is multi-step. So the same sodium chloride formed in single step, the same chloride formed in multi-step. How many steps taken? 1, 2, 3, 4, 5. 5 steps again sodium chloride formed. What is that? SS law says? What is SS law says? According to S law, if a reaction takes place in single step or several step, the energy change is same. In single step energy change is yes, delta HF. Here we got negative, which is equal to enthalpy of sublimation, which is equal to enthalpy of sublimation plus enthalpy of ionization plus enthalpy of dissociation by 2 plus electron affinity plus lattice energy. Yes or no? Therefore, according to S law, if a reaction takes place in single step or several steps, the energy is same. And here the released energy is equal to sum of all these energies. Here the released energy is equal to sum of all these energies. Okay. Another way also you can write enthalpy of formation is equal to enthalpy of sublimation plus enthalpy of ionization plus enthalpy of dissociation by 2 plus enthalpy of electron gain plus lattice energy. Observe that. Why do I put what is that? Plus, already I told you. You see, if you are not or not, I don't know. What I told, electron affinity if you show negative, electron gain enthalpy if you show that is positive. You know the relation. The electron gain enthalpy is equal to minus EA plus 5 by 2 RT. Your lecturer has told to you in electron gain enthalpy of periodic table lesson. So electron affinity is minus, then electron gain enthalpy is plus. Now I want this. Then you bring this side. Then it becomes lattice energy is equal to, if you bring this side, enthalpy of sublimation plus enthalpy of ionization plus enthalpy of dissociation by 2 plus enthalpy of electron gain enthalpy plus, okay na? Otherwise, for your convenience, minus of enthalpy of formation. Why I brought this side minus? I brought this side plus. Is it right or not? So if you know this value, 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 can you calculate lattice energy? Yes, over. This is the practical, experimentally how lattice energies are determining. But actually, I will give you one important note. This process is not for lattice energy determination. Originally, it was used to calculate electron gain enthalpy and ionization energies. But if you know electron gain enthalpy, we can calculate lattice energy. Actually, this process was not designed for lattice energy. This was originally designed for electron affinity to determine, but now we are using for what is that? Lattice energy. But originally it is used to calculate this value. But if you know this value for a element, you can calculate lattice energy. Okay, na? In the examination, any one of the value you will miss. Either 1, 2, 3, 4, 5 or electron enthalpy of formation. All the values they will give you. One value they will miss. You have to calculate that value. Number 2, always you please remember student, the given value always for 1 mole. If they are not giving for 1 mole, you have to convert them for 1 mole. And for example, in the examination they given 2Na plus Cl2 gives rest 2NaCl, delta enthalpy of formation minus 560 kilocalories, they given like this. Is it the enthalpy of formation? No, you have to take minus 560 by 2. Why nana? They given for 2 moles. I have to calculate per 1 mole only. Okay, don't take 2 moles. I thought everybody completed. Now, if you are completed, I will go for the next one, properties of ionic compounds. Anybody having that doubt? Yes, Divit Reddy.
Sir, once explain that how delta dissociation energy by 2.
Sir, we are taking 1 chlorine or 2 chlorines?
Sir, 1 chlorine only no, sir. Half into C. Half Cl.
1 chlorine e kada తీసుకునేది.
Yes, sir. Yes, sir.
But here who is there? Chlorine molecule is there. Yes or no?
Yes, sir. Yes, sir.
We are
Yes, sir.
converting them into 2Cl. The energy released is called enthalpy of dissociation. But I am requiring 1 only. That is why I am taking by 2.
Oh, okay, sir.
Understood? We are taking
Sir, but
half
we took
chlorine.
moles half only, no, sir.
Nana, you are forgetting one point. This is the molecular state I am showing. Okay, na? Even though this is half, generally we are calculating enthalpy of dissociation for 2 chlorines. The value always given for 2 chlorines.
Okay, sir.
Okay, but we are taking 1 chlorine. That is why we are taking half. Enthalpy of definition itself having. What is enthalpy of definition? You please remove the amount of energy required to break up 1 mole chlorine to its gaseous atoms. Shall I repeat one more time? The amount of energy required to break up 1 mole chlorine to its gaseous atom is called enthalpy of dissociation. And you are taking 1 mole chlorine or half mole chlorine?
1 mole chlorine.
The definition is 1 mole chlorine. Okay, I am taking half. Okay, now that is why students are getting confusion. Got my point? Now I am going for, okay. Now I am going for ionic compound for what is that? Properties of ionic compound. Properties of ionic compound. Sir, before that, I want to explain some more. Okay. You please see that in your page number, I think 267 or 268 of your Narana material. Anyway, whatever it is, please write the note. What is that? Lattice energy is always directly proportional to charge products, inversely proportional to size of the cation and size of the anion. From where I got? Lattice energy E is equal to, you wrote minus N naught into Z plus into Z minus into E square by A by R. And what is that? E is directly proportional to charge of the products and inversely proportional to distance between the ions. Distance between the ions is nothing but size of the ions. Yes or no? So you please see the example. Lithium fluoride, cesium iodide. which has more lattice energy? Lithium fluoride has more lattice energy. Why? Because here +1 -1 +1 -1, both charges are same. So which factor I should take? Size factor. As the size increasing, lattice energy decreases. I thought you got the points. Okay. One more example. KBr, lithium fluoride, and what is that? MgO. If I consider first in these two, Li +1, F -1, Mg +2, O -2. Here both are +1 +2. This is +2 -2. That is why it is more. Now we come here, +1 -1. This is charges are same, but we have to consider what? Size. Size is less, lattice energy more. Okay, na? These are the important things. Now you go for example. Okay, lithium fluoride. What is that? Lithium chloride and lithium. What is that? Lithium bromide and lithium iodide. Which is more? Yes, all positive cation only present. But anion also -1 -1 -1. All of them are not depends upon charge because all of them having same charge. But difference is, yes, fluoride is the different, chloride is the different, bromide is the different, iodide is the different. Their size increasing. Okay, as the size increasing, lattice energy decreases. Okay, take one more example. What is that? LiCl, NaCl, KCl, RbCl, and cesium chloride. Now again you come here. All of them +1 -1 +1 -1 +1 -1 +1 -1 +1 -1. So charge cannot be distinguished. Who can distinguish us? All of them having common cation, common anion, common anion. That means who will decide the factor? Yes, this lithium, this lithium, this sodium, this potassium, this rubidium, this cesium decides the lattice energy. Why? This is only different. Remaining charge is same, remaining anion is same. From the left to right, cation size increases. Therefore, lattice energy decreases. You see the answer. Now, for your convenience, I will write one more example. Okay. NaF and CaO, which has more? Yes, Na plus F minus, Ca plus 2, O minus 2. Both are having similar sizes actually. That is the reason. Why? Because lattice energy is more. Okay, for your convenience, I will take one more. Sir, if reactant both are what is it? Gases, no need of sublimation. What is the need of sublimation, right? Jaffa? Okay, I will take one more example. Okay, you take this one. MgO, MgCl2. Okay, MgO, MgCl2 and NaCl. What is the lattice energy order? If they given like this, what is the lattice energy order? Yes, simply you can write. What is that answer? This is the answer. Why, sir? This is divalent, divalent. This is divalent and monovalent. And this is monovalent and monovalent. Yes or no? How, sir? Plus 2, minus 2. Plus 2, minus 1. Plus 1, minus 1. Plus 2 plus 2 greater than, and 2 charge is greater than 2 1 charge. This is the lattice energy order. Okay. Question. FeO and Fe2O3. which is have more lattice energy. Yes, Fe2O3 greater than FeO. Why, sir? Both are having same iron, same oxygen. But iron plus 3, iron plus 2. O minus 2, O minus 2. Trivalent, divalent is greater than divalent, divalent is over. So this is the way you can remember lattice energy. Now I am going for properties of ionic compound. Please see. First property, physical state. What is the physical state of ionic compound? Ionic compounds are, what is that? Solid crystalline, are, what is that? Crystalline solids. What is crystalline solids? What is meaning of crystalline solid? Regular, orderly arrangement in 3D space. Then that is called crystalline solid. Regular or orderly arrangement of particles in 3D space. Like that my ionic compounds are present. Okay, already you saw sodium chloride, already you saw cesium chloride. Yes or no? Number 2, these properties of ionic solids, depends on number of ions forming ionic compound and their shape of the ionic compound and shape. Already you know. Example, NaCl, what is that? FCC structure. Cesium chloride, what is that? BCC structure. And their shape may be different. Yes or no? And number of ions may be different. You know already. How? Coordination number of sodium plus 6. Coordination number of Cl minus is 6. Coordination number of cesium plus 8. Coordination number of Cl minus 8. And here the number of ion, here the number of ion surrounding is different and their shape is different. That's why the properties also different. Okay, na? Sir, my question, very important point. In ionic compounds, there is no real molecules. There is no real molecules. Always, what is that? Always it has non-momentary, okay, non-momentary ions present at fixed positions with a definite geometry. Correct or not? In ionic compound, there is no real molecule. Always it has non-momentary ion present at a fixed position with a definite geometry. Perfect or not, you see? Correct or not? Everybody. Yes, sodium chloride having one geometry, cesium chloride one geometry. The ions never moves. They always present as fixed position. Because of the fixed position only, they have definite geometry. This is the first important point. So, ionic compounds are solids. Why do they solid? Because of strong attraction, they are very closer. Yes or no? Why do they solid? Because of strong attraction Ions are closer. Ions are closer. If they are closer, automatically they form solid. Why crystalline solid? The regularly orderly arrangement of ions is there. Yes, they are not irregular. Perfect regular shapes are there. That is why they are, what is that, Nana? Ionic solids, crystalline solids. Up to this, very important points. In your book, in your Narayana material, everywhere you see, simply they will write, what is physical state? They are crystalline solids. Ante. There is no explanation. Otherwise, you check it your notes. There is no explanation. Perfectly. Therefore, ionic bonds. Okay, there is no ionic bond is non-directional. Non-directional. Always we are writing formula unit rather than molecule. Yes or no? Why, sir? Yesterday I shown you every Na plus. Is it having only one Cl minus? No, there are 6 Cl minus around that. Now tell me, which Na plus, which Cl minus attracts? Is it? No, all Cl minuses are attracting Na plus. Therefore, it is non-directional. And are you writing Na6Cl6? No, we are writing Na plus and Cl minus. And what is the meaning? We are writing formula unit, but not as a molecule. Yes or no? This is the important points regarding physical state. Afternoon class, I will continue. Okay, na? Afternoon class, I will continue. Sir, within last 10 minutes, I observed 10 members left. Why can't you sit for 10 minutes? Huh? Just 950 also I saw 129 members. Jaffalara, Kuflis, Tuplis, Dafas, Jangris, Chandrasai.
Sorry, sir. Lower hand.
Akash Kumar, Rishikesh.
Sir, once again, can you tell why the structures are different?
Where?
Say in ionic compound.
Because the size of cation and anion is different. Na?
Yes, sir.
If the size of cation, for example, small laddus and big laddus, if you made, mummy made small laddus and mummy made big laddus. If you take one vessel, is it both are fitting in the same way?
No, sir.
That is, as the size is different, their fitting will be different. Their geometry will be different. Yes or no?
Yes, sir.
Their packing will be different. Automatically, their shape will be different.
Okay, sir.
Bye-bye.
Thank you, sir. Bye, sir.